All right, I guess we will kick this off then. And George, how about you and I? We'll do a quick little intro here. I'm Brian Killo from NASA. I run the CEOS Systems Engineering Office and happy to be here today to talk to you about Open Data Cube Sandbox. We'll do a demo and discussion time. And my co-host here, go ahead, George.
Hi, I'm George Dyke, and I've been working a lot with Brian in the Systems Engineering Office for a number of years on CEOS things, including Open Data Cube. And this is my first Geo Symposium, unfortunately not in Geneva, but maybe next time I'll get to go to Geneva. But anyway, I'm looking forward to this session and demo with Brian.
Sounds great. So I am going to jump on and share my screen with everybody and start off with a few charts here and presentation. So let me do that now. And hopefully you, everyone can see that. Holler at me, George, if that's not possible, but it looks like it's going to work. Okay. Again, George and I did our introductions here on Open Data Cube Sandbox and the demo. So this is how we're going to run the session today. We'll do a 15-minute intro. I'm going to give you some background on the Data Cube and this sandbox concept and what has been developed. The second part of the session will be some demos. George is going to show you cloud coverage and water detection demo, how these sandbox tools work. I will show you a different one, which is a radar application, and I'll do that a fairly short session. And then at the end, we'll leave some time for interactive Q&A. So our ultimate goal here is to demonstrate this new sandbox tool. It runs on Google Colab and connects to Google Earth Engine data sets. We've just completed this in the past, I'd say a few weeks or a month. So we're excited to show it to many of you. And hopefully this tool will be very useful for training and capacity building, and it can certainly be used to run any small scale applications that you want. And I'll talk more about the limitations. So a little bit about the Open Data Cube. It's the ODC in its simplest explanation. It's a geospatial data management framework, and it gives you the ability to take satellite data sets. We index them. We create an index of the metadata, which basically describes where the content is in a stack of files. So if I want to get at certain pixels, I want to get at a certain range of pixels in space and in time, I query that metadata index through my Open Data Cube API, and then I connect that to an application algorithm on the far right there that you see. So we build these application algorithms in Python, Jupyter notebooks. They talk to the Open Data Cube API and query to try to get satellite data from an index, a database, and that's how it all connects. But the glue to all of this is the Data Cube infrastructure in the middle. Otherwise, we just be looking at a stack of files, a stack of scenes. So if you need more information, opendatacube.org is where you can find everything you need to know about the Data Cube activities. So what we've been doing in the past, everything started in Australia. CSIRO and Geoscience Australia were the ones that pioneered the Data Cube activity. And then we as a group within CEOS, several agencies, GA, CSIRO, NASA, and USGS came together and created this Open Data Cube concept that would take what was done in Australia and brand it and make it available to the world in a global way. We demonstrated this in Africa with a regional demo, and that now has moved on to Digital Earth Africa, which has become an entire project on its own. As you see on the right, there are now others out there. Digital Earth Pacific is in early planning stages, and Digital Earth Americas as well. So we expect some of these regional cubes to be more popular and to be more active in the future. And right now, I would say we've impacted over 100 countries in some way. They've either inquired or they have data cubes of their own. So we continue to improve the code and the applications and learning how to run better on cloud computing methods. This whole concept we're showing you here today is a connection to Google Earth's data sets. And we've done this on Amazon, and we're now testing it actually on Microsoft as well. So there's a lot of potential for using the Open Data Cube as the infrastructure to query the data. And by pulling all of these regional cubes together, our goal is to have a global network of cubes around the world where there are users that share and test algorithms and methods. And it gives us the ability to work together and use algorithms and data in a cooperative fashion. And so you'll see some demonstrations about what we can do. So now for the Open Data Cube Sandbox. This is the new piece that we've just unveiled, and we've developed this within the Systems Engineering Office. And you can find everything you need to know. The best place to go would be openearthalliance.org/sandbox. And on the far right, the easiest explanation is we took the Open Data Cube framework. We matched that up with Google Colab. That's the little CO you see on the right. Google Colab is the Jupyter Notebook interface that Google provides, and it's a free interface, very similar to Earth Engine in that it's free and open for anyone to program in. So we installed Open Data Cube in that, and then we connect it to Earth Engine data sets. So it all works quite nicely. Took a little bit of tweaking and playing around to get it to work well. And this is what we're going to demonstrate with you today. There are a few things you need. There's two things that you have to access this. Number one, you need a Google account. So if you have a Gmail account or any kind of a Google account, you're set. The second thing you need is Earth Engine authorization. So many people have used Earth Engine, and a lot of times it's linked to your Google account. May or may not be the case. But if you get a Google account and apply for Earth Engine authorization, there's instructions on our Sandbox link. That gets you in and allows you to run. And we've built a number of sample applications, and I'm going to demonstrate a couple of those here today, George and I. But we've got things like cloud statistics, which is a survey of Landsat 8 and Sentinel-2 data, going through the whole archive, anywhere you want, learn about what are good scenes and bad scenes, spectral products, cloud filtering and building mosaics, vegetation change and water extent, phenology, which is the time series growth, and nighttime lights and mission coincidences and radar products. And I'll show you on the next page. Here's what a few of the outputs look like. And each of these is a screenshot of output from some of our sample notebooks that are out there for you. You can see in the top right is vegetation phenology. The bottom right is a fractional cover image. The gray image there is the radar. There's night lights. There's mission coincidences in the bottom left. The cloud statistics are on the left. And then the very colorful one in the top center is the WAFs, the water observation from space. Lots of great algorithms out there where we've given you a notebook with a sample case ready to run. And then we'll show you how you can modify that. And you can run any of these notebooks anywhere in the world on any region that you want. So some closing comments here before we dive into the demos. The Colab environment has some limits. It's not a massive environment that you can run large scale analyses. So you have to be a bit careful in what you choose in terms of the spatial region that you select and the time window that you select. So it has about 12 gigabytes of RAM memory. We've been doing some testing, and I see OK is on the line, and he's helped us do some testing about the limitations of all of this. So we're learning. There's 100 gigabytes of storage, but that storage is limited to the session that you're in. But what you can do is you can store it, and you can also store results in your in your own Google Cloud account or your Google Drive account. So anytime you create a GeoTIFF or some sort of output product, which is easily done, you can store that and use it offline without a problem. So again, small analyses are the target here. We've created a user forum, and we'd like users to start to go there, answer their questions, and post questions there and share any knowledge. Forum.openearthalliance.org. That will get you to a user forum where you can post that question, and we'll be keeping an eye on that. So our idea here for the next 20-25 minutes are to show you some live demos. Feel free to follow along. You can try to run these on your own if you want to go out and check out the environment and go to the GitHub where we have the notebooks listed. Otherwise, you might just want to follow along and see how we do it, and then go try it on your own a little bit later. So just a reminder here that the sandbox is at openearthalliance.org/sandbox. The user forum is forum.openearthalliance.org. And if you need more information on the ODC website or our Twitter page, check us out. So now I'm going to leave this chart to George. He's going to talk to you about his demo. Take it away, George.
Yeah, sure, Brian. I just posted the link in the chat there if anyone wants to have a look at the sandbox page. What we're going to do is we're going to run you through a getting started notebook and the page, and then talk a little bit about a simple application that does cloud statistics using Landsat 8. We'll try and show you running in an arbitrary location in the world, although to appease the patrons of live demos, I've also preloaded some notebooks just in case that doesn't work. And then we'll also talk about another application, water observations from space. So I'm just going to find the screen share. Screen share. This will stop. Yes, do that.
All right, I stopped sharing, George, so I think you can take it, right?
Yeah, so you should see my browser window now. Does that sound right?
Yes.
Okay. So how you get started with this sandbox is you can go to openearthalliance.org, and at the top there's a link that says play in the sandbox. Click here, and that'll take you to this sandbox page. As Brian mentioned, you need to set up a couple of accounts. A lot of people have these already, but if not, there's a way to do it here. The authorization is generally fairly quick, but it can take a couple days, although most people have been telling us it takes minutes or hours. So hopefully that's the case. Then down below, there's a lot of detailed instructions if you get stuck or need to figure it out. But if you just click on this Open in Colab button right in the middle, then that will open up the Getting Started notebook for ODC running on Google Colab. One of the things that we really wanted to have here, and as Brian mentioned, this is a sort of training and outreach goal. We wanted to have it so that you could be running just with a single click of a URL. And so this will get you up and running. There's some information on the ODC framework, including lots of links to the outside, a bit on Jupyter Notebooks if you've never used them, and an explanation of how you will have to authorize your account. And I'll show you that in a few minutes. And then some simple demonstrations of loading data sets. At this point, we have these data sets indexed in the cube. So Landsat 7, 8, Sentinel-1, 2, and VIRS. These are all from the Google Earth Engine catalog. It's possible to index other data sets, but these are the ones we've gotten to at this point. And there is some instructions on how to index your own chosen data sets from the Google catalog if you'd rather do that. There's a bit on how to load data. And then down the very bottom here is Brian mentioned a few sort of example notebooks, and there are links to all of them here. They're also on GitHub, so you can get them directly from GitHub. But we're going to run through a couple of them in this session. So the first one I'm going to talk about is this Cloud Statistics Landsat 8. I'll also talk about this water observations from space example. And then Brian is going to show you the Sentinel-1 data viewer as well. But all of these should run relatively well. And you can just click the open in Colab, which I'll show you in a moment, and that'll get up and running. So first with the cloud statistics, this is the pre-run version that I did earlier. And I wanted to talk you through a little bit of it. There's a number of header items that just, install the ODC framework. As Brian mentioned, there are virtual machines behind each of these notebooks. So this sets it up. This command will load the data index so that ODC knows how to find the data in Earth Engine. And then this exact line here is where the Earth Engine ODC connection is made. So I've already run all of those. We're looking at Landsat 8 data, and this example we've got is in Mombasa, Kenya, and it's for 2020. Okay, so I'm gonna show you the cloud statistics output of that in a minute. But what I wanted to do is show you that this can be run anywhere. So I'm just going to go back to the Getting Started notebook and click a new instance of this notebook. So opening it up in Colab. And then I'm going to, sorry about this, Mike. I'm going to set this notebook off running. It's going to take a second. While we do that, I'm going to bravely find an arbitrary place in the world. Just keep this notebook running. And now you get to see, right. So here's where the lat long was defined. I noticed there was some interesting stuff up here. Let's try Cape York. For those of you who've never been to Australia. So I'm going to copy the lat long for Cape York. Put that in here. So this is now, and I'm also going to change the date range to be 2021, sort of today. So that's going to run here, and you'll see in the preview map, it's a rather, Kakadu National Park, beautiful place. So we're going to let this load in the background. It does take a bit of time to load. And while we're doing that, I'm going to go back to the preloaded version for Mombasa and show you the kind of outputs we can expect. So as I mentioned, this is the preview map for Mombasa, Kenya. That red box is where we're focused on. We've loaded the data set here, and now we have a table. And these are all the Landsat 8 takes over Mombasa, over that square for 2020, and including the clean percentage, or how cloud free it is. So the higher the better in this case. And then this notebook also generates a sort of a graph, so you can quickly pick out, this one's quite a clear scene, this one's very cloudy at a glance. And then you can also see a preview of the scene. So if we go back up here, you'll see some numbers. So let's pick this one, number 1, it's 75% cloudy. So in these notebooks, we've put modify here in places where you can safely change things around. So we can just shift this to number 1, and let's see, oops, there isn't, if we can get that now. Of course, that's not going to load properly. Let me just check what's happened over here. Yeah, okay, I've noticed sometimes it interferes. So we'll show the scenes in this one. So we're back now in Cape York, and we have 2021 data. For those of you who might know Australia, Cape York is very tropical, so it's rainy in this early part of the year and nice and clear later on in the year. So let's see if we can look at some slices of these that we get from these data sets here. It's just going to have to load for a little minute. And while that's loading, I was going to show you back on this page, the OEA page. Brian mentioned the forum. If you click on Learn, then you'll find the forum here. So you're welcome again. You'll find a topic in there on getting started with ODC Sandbox and Google Colab. And so this should get you going. And we'd welcome any questions or anything in there as well as you go. So let's see if we have any more luck here. So now slice 2. So that's our Cape York data. Slice 2 is only 24% clear. Let's chance our arms and go for the last slice in the stack here. Oops, did I get that right? No, it should be 7. So that one's, it's not bad. Let's see what 7 is like. So there you go. If you're looking for a clear scene over Cape York, that's about as good as you're going to get. And we have true color and false color images shown there. So look, that's an example of this CloudStats notebook. You can run it anywhere, and it's a bit of an intro notebook. It's a good getting started. The last one I'm going to show you is the water extent. So in our list of notebooks, this is this one here. And it's a demonstration of a Geoscience Australia algorithm that finds probability of water in a certain area over a certain time frame using, we've done this with both Landsat and I believe Sentinel as well, but I'm going to show you the Landsat one. One of the reasons is that the Sentinel ones have a lot more data and take a lot longer to load or have to cover a smaller area. So here we're back in our familiar Mombasa area, but we've collected data for 3 years. So from the start of 2018 until the end of 2020. And it's run a water classifier over those areas for those 3 years. This is the extent of the data set here. You're not really meant to read this, but it just sort of shows the different structures of data that we've loaded. And down the bottom, this is just a percent classified as water over that 3-year period. So you might remember from the Mombasa scene, this is sort of the port down here, and then there's a river, very watery, obviously the red, not water. And then we've got some river sort of maybe mud plains or flood plains or tidal plains here. It's hard to say exactly, but they're sort of water between 40 and 60% of the time based on this classifier. So those are the 2 examples I had. I really would encourage you to get in there, have a look at these, give them a try. And like Brian said, this is the first version that we've done. We're happy for comments and feedback. The forum's probably the easiest, best way. And we're hoping to add more and more based on both what you do with it and also as we get more and more sophisticated with it as well. So Brian, that's all I had, but yeah.
All right, sounds good. I will jump over. I'll take the screen back here, George.
Yeah, I just stopped.
All right, and let me go back here to my PowerPoint. And can you see that okay? Radar demo, do you see that, George?
Yeah, radar demo.
Very good. All right, so the next, I want to show you a demo that we have for radar data. There are not many radar data users out there. I think these are data sets that frankly have only been around free and open in large volumes since about 2017. And we are trying to promote the use of these data more often, and we're learning and understanding how to interpret them. So I'll start by saying that first bullet, if you want to learn more about how to interpret this radar data. Okay, Rosenquist, who is on, I spelled your name wrong. Okay, my apologies. We had him develop a layman's guide to radar. So if you just do a little Google search on layman's guide to radar, you will find that document. It's really an excellent and short compilation of how to interpret the various C-band and L-band radar results that you see, and it'll kind of get you going and give you an idea about this data. So the Sentinel-1 data that is stored in Google Earth Engine, it's C-band backscatter intensity. So basically it's a radar pulse coming from the satellite at an angle, scattering off of the target. And if there's vegetation in the view or scattering, things that can scatter back, there'll be a return pulse. If there's a flat surface, something like water, it will appear very dark because all of the energy is scattered completely away in the opposite direction. So what we get is we get a polarized view of this. You get vertical polarization and vertical horizontal. So that's your VV and VH. Those are the two bands. If you think of those kind of in a comparison to optical bands where you might get red, green, blue, and near infrared, your radar data has VV and VH bands, the way that this data is prepared. And it's at 10-meter spatial resolution. And we have that data since 2017 on Google Earth Engine. Now, we have to be careful because this data does not include radiometric terrain correction. So there are some issues. If you're looking at results in high elevation areas, you're going to get these little things called layover and shadowing. And basically what that means is because of the viewing angle, and we're looking at terrain that has height to it, or even if you're looking in urban areas, you will see there'll be shadows and there will be layover return pulses, and you can see them here over a mountain range. Now this is just, I don't know exactly where this is, but you can see the bright return pulse for the layover. The shadows are in the dark area, so obviously the satellite must be on the top of this image, up above, looking at that terrain. So basically, just be careful. Be careful in how you interpret the data in the Google Earth Engine because of the fact that this terrain correction is not in the data. You could get some false results. That said, there's a lot of interesting things you can see, and there's still a ton of value in doing this. So the notebook that we developed here, I'll show you, it's got some histograms, some single data images and multi-data images, and it's really quite interesting. So we will come back to this, but right now I'm going to hop over and look at my desktop so that you can, oh, let's see if I can do all this correctly here. Well, hold on a second. If I can do this without completely messing up here. Let me try and just go straight to my Chrome. Do you see my Chrome there, George?
Yeah, I see the GitHub repository.
Very good. Okay. So when you go to the GitHub repository, if you look for a notebook called Colab S1 Data Viewer, that's the one we're talking about here, Sentinel-1 Data Viewer. And if you click on that, here's what you will see. So in any of these notebooks, before you actually run them and get going, if you just scroll down through the notebook, you will see the sample case already run for you, and it shows you some of the output products. So it's just interesting before you run them, just to scan down and see what you're looking at. So again, George told you a little bit about how data is loaded here. This is a sample case in Bangladesh, a rice cropping region. You can see the area here. If I zoom out, you'll see it's not far from the coast. Here it is, Bangladesh. Very well-known rice cropping area. It's loading up the VV and VH data. Here are the dates. And here is a histogram plot. So how do we interpret the histogram plot? This is VV and VH. This is basically the number of pixels. And over here is in the y-axis, and the response in dBs. So this the response in dBs and the number of pixels in the y-axis. Basically, this big hump here are land pixels, and this hump here on the left are water pixels. So if you're looking at a scene that's entirely land, you're only going to get this hump on the right because all the pixels will primarily be land. But if you get a bunch of water in your scene, you'll see this variation between water, again, in both the VV and VH response. It does not have a strong return signal because most of the energy completely reflects away. And so therefore you get a very low dB response, which is what we would expect. So if we look at these images, here's the VV backscatter. Notice the river is very dark. That's what we would expect. And these areas here that are dark are probably either bare soil or a lot of times urban areas or areas that are undeveloped, lack of vegetation, tend to be darker. Areas that are brighter either are vegetation, or as you get into urban areas and you get a lot of strong reflections, you can get some very bright areas in urban. Now, if I pull this together and look at a colorful image, this is one of our favorite ways to look at radar data. You look at an RGB where you assign the red band to VV, the green to VH, and the blue to the ratio VVBH. And here's what you get. Now notice the difference. Things start to stand out a little bit better. The areas here in this greenish yellow, those are scattering areas. So these are probably trees and a forested area on the perimeter. You can see the river here. What you'll see in the pink areas tend to be urban spots, and then you start to get in the blue, which is your mix of vegetation. So it's kind of hard to distinguish all those details, but what you can do to really find some interesting stuff in radar is look at multi-date products. So in this case, what we did is we assigned the first scene to the 0 index, and that is January 5th. The second green color we assigned to March, and the blue color we assigned to May. So now we're looking at January, March, and May, assigning colors. So if the scattering is high in any one of those particular dates, that color will be accentuated. And there's a color interpretation here. But what I want to show you is look at the colors. Pretty interesting what you're seeing here. So the areas that are white basically say the scattering is strong in all 3 dates and equally so. And that's basically because these areas are probably forested. There's not a lot of change. Nothing has happened. In areas where there's a lot of change, remember we assigned red, green, blue. The red says this little area in red, we're getting a strong scattering from this area here in red in January, much more than in March or May. That's basically telling you a little bit about the growing cycle of that rice crop. These green areas down here, red, green, so green was the one that was in March. Those are peaking in March, and then the blue areas are peaking in May. This can tell you an awful lot about your cropping. So let me go over and I'm going to show you an interesting one that I ran for San Miguel and El Salvador. Now, what you can do with this notebook is you can modify this very slightly and you can detect flooding and water very nicely, and also land change. So I entered a new area, San Miguel, El Salvador. This was an area that in 2020, in late May of 2020, a hurricane passed through here. And the hurricane flooded. This was an area that was flooded, and it actually was added to the disasters charter. If those of you are aware of the disaster charter, that is an area, any areas in the world that have a disaster and they want to acquire data rapidly from a bunch of different sources to help support the region. Well, that's how I found this site. I went on disasters charter, I saw that a flood had occurred, and you can see it's on the coast here in El Salvador. So I wanted to see, could I see the flooding with this simple notebook? So here are the dates that we have, early May, and then we go all the way to the 10th one is late June. You have to be careful here in that there's a mix here of viewing angles. So there's a mix of data. Sometimes you're going to see some things coming ascending and some things coming descending. So it's best to compare ascending angles only or descending angles only. And remember that Sentinel-1 data is separated by 12 days. So if you look for things that are separated by 12 days, you see scene 1 and scene 3 are separated by exactly 12 days. That tells me they're either both ascending or both descending. That is what I would prefer to use. So here we go. I'm looking at scene 4. Notice the histogram. It's all land. There's a little bit of water in here, but you can't quite see it. In other words, the number of pixels that are water, very small number, because this is not looking at the coast. Here's the scattering, but there is some water in this scene. So in this scene, in the top is a lake right here. This is the edge of a mountain range. And then there's some areas in here where some people live, but basically this is the lake of importance. And this was an area that flooded. So now we look at this in the RGB image, a lot more colorful, easier to see. Again, these pink areas tend to be areas that are urban because they get a little bit of a bright return pulse. The dark areas here in dark blue are water. So now let's look at a land change product. So what I did was I assigned, we're going to look at scene 4 and 6. Sorry to make you dizzy here, but let's go back up and see what scene 4 and 6 are. We're going to look at May the 27th versus June the 8th. I believe the storm came over around June the 1st or 2nd. So basically the storm is right between these two dates, 4 and 6. So we come back here and we say, I'm going to assign the red color to 4 and the green and the blue to 6. And so I'm going to look at the difference between the two, and here's what we get. So everything that is red has basically decreased scattering when it has gone from 4 to 6. Because if scene 4 is red and it is brighter than 6, then what it is saying is it has lost scattering. So its scattering return energy has dropped significantly, and those are dark red. So what does that mean? Well, if scattering has dropped significantly, I've probably gone from vegetation to water in the case of flooding. And that's exactly what has happened here. The areas in blue are increased scattering from 4 to 6. What does that mean? That's possibly vegetation that is now wet or slight change in how that vegetation, it's scattering a bit more after the storm than before the storm. And let's go down and see what's happened. So the last thing I want to show you, and this is the best way to really find precisely where the flooding. I compare scene 4 to scene 6, and I apply a threshold which basically says only color red those pixels which lost more than 7 dBs, and color green those pixels which gained more than 7 dBs. Well, it's unlikely we're going to see a lot of gain here, because we're not planning new vegetation in a matter of weeks, but we're definitely going to see a significant drop in the areas where there's flooding. And if we go down, there's the final scene. So I compared this result to the result that was online for the disasters charter that was prepared by ESA. And there was also another product that was prepared by another radar satellite. This result that I ran here in just 5 minutes very quickly on my own matched their results almost identically, perfectly. And so all of these areas in red, in bright red, clearly show the newly flooded areas. And this is something that if a local researcher or government person wanted to monitor, every time a new scene comes every 12 days, they could go back and run this notebook very quickly and notice the dissipation and change in the flooding. So the flooding will eventually go away, and this area will probably start to dry up because these are probably just temporary flood zones. And you can start to see the return to normalcy, so to speak. So let me go back and take a whoop. Where was I here? Hang on a second. I want to get back to hold on here. All right, now I got to get back, George, to my stop sharing. And why is it not doing it? Oh, you know what it was? It was I think I turned the controls off of. There it is, turn my controls off. So let me stop sharing there and I'll go back. So what we did in the end of this, I'm gonna go back and just share my PowerPoint one last time and share this one with you. That notebook that I just showed you, once you get through the Earth Engine authorization step, you enter your Earth Engine piece, those first couple steps, and it loads up the Open Data Cube. From that point forward, it takes about 3 minutes to run that notebook for a fairly small region. It's not a problem. Again, look for the modify here tags at the beginning of code blocks to identify areas where you can change. And this is the information here that I just had entered for you. This is actually a photo of that region in San Miguel, El Salvador. There's a volcano in the background, but basically this is the area that had quite a bit of flooding after that storm. So it's amazing what can be done with all of this. George and I just gave you a short glimpse into the capabilities of this new ODC Google Colab sandbox that we've provided. So I think we'll stop there. George and I are going to monitor the chat here and keep an eye on things, and we'll use these last 15 minutes to entertain any questions. So let's take a look. George, did you see any you want to jump on?
There's a couple questions in the chat, Brian. Flavia was asking about the basic pre-processing and whether it's possible to go back and redo that. And that is, I wrote an answer in the chat there, but basically we're working with the data set that's in the Google Earth Engine catalog. So it's not really possible. However, I did post a link to an interesting tool set and framework that someone has done, which does allow you to apply some processing to the data set. And actually, the next point, I think, from Ace was around FAO CEPL, and that exact framework link that I posted has been used in the CEPL tool, which is a great tool. But his question was really around, there are a lot of platforms out there, so why would I prefer to use this one? From my perspective, Brian and I have been working a lot on Open Data Cube. And so we wanted to have an environment where we could run Open Data Cube and you could plug in your existing Open Data Cube applications without having to do all of the painful setup and things that come with software environments. And so really achieving that single click was our goal. Certainly CEPL is a great tool. Google Earth Engine itself is a great tool. And I just discovered the other day GEE Map, which is another excellent tool, which does a lot of these similar things. So yeah, there's a lot of choices. Definitely, I guess we're looking at the Open Data Cube community specifically with this one. I think, Brian, that's pretty fair to say?
Yeah, so I've got a few thoughts on that. When we got into this, we certainly recognized there are a lot of tools out there. There's no doubt there's a lot of choices that users have. What I was trying to fill with doing this is a niche that I think was unserved per se. One is that if we created a framework that's very simple, has some example notebooks, I think this can be a wonderful training and capacity building tool. You can use this and scale this unlimited to users in a class, let's say, that are doing Python training, learning how to use satellite data, doing some simplified things. So I think this tool will be very useful for training people just some simple things on how to interact with satellite data, maybe become a little familiar with Python and notebooks and get them thinking about the possibilities. So that was one reason. The second thing that I don't see in these other tools is the diversity of data sets. The large majority of tools you see out there, you go to Sentinel Hub and you go to other tools or even SQL, there's only 2 or 3 core data sets. And what I wanted to do was to promote multiple data sets in here. So you'll see one of the algorithms I have is mission coincidences. I haven't found any other tool out there, notebook, that searches for when does Landsat 8 and Sentinel-2 cross each other for a CalVal opportunity, or when does Sentinel-1 and Sentinel-2 cross each other for a CalVal opportunity. There's a notebook that we built just for mission coincidences. There's a notebook we have out there for night lights. And so looking at night lights in a simplistic way and looking at the time series plot of nightlight intensity, that's a great thing in storms and a great thing to show urban extent. And so there are a bunch of other data sets in Google Earth Engine that we haven't even touched yet. And so one of the things I'd like to do is build a couple small notebooks that perhaps use multiple data sets to give us a product that uses information from multiple data sets to create an interesting product. So it's kind of a mix of things, a little bit more focused on let's get people more trained and interested in data and interested in Python programming and notebooks. And let's also give them a look into some different data sets and some interoperable ones. So that was kind of one of my things. One other thing I wanted to mention, it was back on the comment from Flavia about the radar data. We are looking into what it would take. There are some pre-processing scripts out there that people have generated. There's a fairly new one out there for how to take the Google Earth Engine and run a script that pre-processes that data, uses a digital elevation model, basically turns it into the radiometric terrain corrected. I don't know if we're going to have that capability in Colab because that's going to be more complicated. But the speckle filter one is probably something we could add. We could add a little code block that would allow you to do a 3x3, 5x5 speckle filter, something like that. So that's something we could add in later and think about. Is there anything else, George? Any new ones popped up? Go ahead.
Okay has asked. I promise we didn't give him this question. I'm trying to think of an answer as I read it. Can a user with some notebook background add their own new modules to the Colab notebooks? There's no reason why not. In fact, it's quite easy to copy what we've done and use it as a starting point and build your own. You know, we've set up a GitHub repository, so in the future there's probably no reason why we can't also have new scripts added in there by other GitHub users. It's really sort of a beginning there. And I think we also did set, you'll notice the notebooks have a numbering, I wouldn't call it a system yet, but has numbering on them. And so I think we imagine maybe having different sort of chapters or allotments of them. And definitely, I think like a user contributed, or, you know, well, I don't know what the right term is, but that would be really interesting. So I don't know what you think of that, Brian.
Yeah, I agree, George. Everything you said, right on. I would hope that there are other users out there that come up with some good ideas and some other potential, you know, notebooks and adding their own modules. So one way you could do that is contact us through the user forum, and we'll work with you. We can get our team to add some of the necessary front end pieces to any notebook ideas you have. Or if you want to design a notebook to do a certain thing and you say, you know, I've got this application that I would really like to get this product. How could I build that in a notebook with our help and get it to run so that it sits on this GitHub and it's there all the time? I'm happy to do that. You know, again, it has to be something fairly small and reasonable that's going to run within the, you know, the potential of this system, because it's, you know, it's limited. They're giving you free processing, so they're not going to give you the moon, but they're going to give you a decent amount of capability. But yeah, we'll work with anybody to do that. There was another question there, Paula, who said about the GeoKnowledge Hub. That is definitely my intent, Paolo, to take what we've done here today, to package this up, and to have it as a package within the GeoKnowledge Hub. I think this would be ideal, and actually from the beginning, that was always my intent. So I'll be in touch with you. We'll definitely move that forward. Any other questions in here? We've got a few more minutes here.
There was one other point, Brian, I thought of about the user contributed. One of the attractive things about Colab is, and I've only started using it recently, but its original intent was around machine learning, really as an environment for experimenting with machine learning. And so I think, there are already ways to bring Earth Engine satellite data into Colab, but this is another way to do that. And I think that's, the more ways we can try and explore machine learning applications, probably the better. So.
And there's a comment here from Ace Aksoy about using this for capacity building and training sessions. We'd love for you to do that. And if there's anything we could do to help you, like if there's another notebook, sort of a baseline notebook you'd like to set up for a training session, let us know. We can help you do that. Ultimately, what I'd like this whole thing to be is a community of users that has ideas, and maybe they bring them to the forum and we help each other. And then eventually that GitHub that we have grows a bit. And then you go to the GitHub and you grab the notebook you want and you run it in Colab at any time you want. And it sits there for forever. And so that's what I'm hoping we can move towards. So we'll help you get there if you feel free to contact us and do that. So a few other comments there. Great way to demonstrate use cases. Nice examples. I definitely think that these are going to be valuable for introducing people to Earth observation. So it takes you one step further. A lot of times when you go to these tools out there, they're a user interface with that, you just a few clicks, and next thing you know, you've got some image that magically appears. The difference here is you kind of see a little behind the scenes about what's happening. You learn a little bit more about, I'm going to this data set, I'm loading some pixels in, I'm doing some modification and arranging of those pixels, and then I'm running a script. And you can learn Python on the fly through these things. You can learn a little bit more about the database structure and how satellite data is compiled, and you'll learn how to interpret the data a little bit more the more you look at it. So I think there's a ton of value here. I'm excited to start to use this for future training sessions. We have one coming up. We're doing a Jupyter Notebook webinar on July 21st. That's going to be sponsored by CIOS. We're going to do one session for eastern part of the world, one session for the western part of the world. We're going to do it twice in a day. And one of the ideas there is for a couple different agencies to demonstrate what they can do with these tools. And I'll be showing this tool again. Do you have a community exchange of codes? For example, the Brazil data cube. We know there's a lot of other data cubes out there. So as it is right now, we don't have much of a community of exchange. This whole idea of creating the forum, so the forum.openearthalliance.org, this was our first attempt to have a broader community of people talking about applications and notebooks and things like that. Now, there is a community, if you go to opendatacube.org, that community is more about core code developers. So though there's a Slack channel there. So these are people that are developing the core Open Data Cube code and maybe machine learning, a lot more deeper involved stuff. But I kind of looking at our forum is closer to the user in a sense that we want to target applications and use cases. And that's what we're kind of focused on. So if there's a core code issue, I'm going to go back to those Open Data Cube guys in their forum. But right now we don't have links with others, but hopefully that'll come with time with these other data cubes, like Greg Giuliani, the Swiss Data Cube, the folks in Brazil, I think could help us. And
something else, Brian, is a lot of these examples are based on work that you've been doing in a lot of other data cubes. So some like that cloud stats one started, I think, in the African regional data cube and has been run on Digital Earth Australia. So there is a level of interoperability. It's not quite plug and play because you have to match with the data structure and data names in behind it. But there is a level of interoperability there that could be the basis for a bit more of an exchange. So,
yeah. And so if anybody out there, I know we're getting near the end here, we just have a couple minutes. Okay, made a comment in there. He found the instructions clear and he was able to do it for the first time. I threw this at a few of my summer students the other day. They were able to get it running for the first time. So it is something that, if you can go out on the web and Google and move around the internet, you can probably do this quite easily. So I'm excited for other people to try this out, see what they think about it, maybe change the location to a spot near you and run a little case and say, well, what's the Landsat 8 or Sentinel-2 data over my house look like? It's a really cool thing to try to do. And, I could see even taking this to high school students, right, and letting them play around with this and try this out on their own. So we're excited about the potential for this. We'd love your feedback. Please contact us. Let us know what we can do to make this better, how you could see this being used in other forums, and we welcome that feedback. Any last comments, George, on your side?
It just reminded me that this week my 8-year-old daughter was homesick from school and I had her running Google Colab Python scripting. So yes, it is possible. Not quite Open Data Cube, but it is possible to do this if you have a pretty basic.
Great. That's right. Now you teach her how to look at radar data over your house, and then OK will be very impressed.
Yeah, no, and she knows OK as well. So anyway, that's all beside the point.
Fantastic. All right. Well, we're near the close here. Once again, thanks to everybody for attending, and we appreciate this opportunity. Have a good day, evening, and evening for you, George, and a good afternoon for those in Europe. Cheers.
Yeah, thanks, everyone.